Hello, I'm Keith McConnell here for Science Daily. I've asked Dr. Wilson to come in and tell us a little bit about his project in the 60s, which many of you probably don't know about, that helped to revolutionize a used to be a very obscure branch of physics. So, if you would, tell us your full name and a little bit more about your project.
Well, thank you for having me. My name is Dr. Robert Wilson, and my project was centered on the field of radio astronomy. Um, my work on the project started when I came to Bell Labs in 1962, 63-ish, which was the same year that the Telstar satellite was launched. If you remember that or not, I don't know. The launch of the satellite made the previous satellite, the Echo, obsolete. So we actually acquired the antenna from the satellite and discovered evidence of cosmic background radiation in 1963, which changed the field of cosmology.
Okay, so in the beginning, what were you guys trying to do or find?
Well, actually, we were not looking for cosmic background radiation. We were trying using masers to measure, amplify, and map weak radio signals coming from the Milky Way and between other galaxies as well. Uh, well, to do that, we had to suppress all recognizable interferences, of course, such as radar, and outside noise. And we even supercooled the receiver with liquid nitrogen to eliminate noise coming from within it. So we had to do a lot to get that, but we were not looking for what we found.
All right, right. Um, so, in a lot of cases, the location of an experiment is pretty important to its outcome. Where did the project or experiment occur?
Well, that's exactly the point. It has the location is key, so we had to find a really quiet place to do this, so we didn't have as much um, outside noise. So we picked Nolendale, New Jersey, I believe, in the Crawford Hills to do this.
Okay, so just a little bit of background for younger viewers who, of course, weren't alive during this event. What other significant events were happening around the world at the time that people can relate to from history books?
Okay, around that time, Lyndon B. Johnson became president after the assassination of JFK. Beatlemania really took off, became huge. Martin Luther King delivered his "I Have a Dream" speech. Roger Staubach won the Heisman Trophy. Russia sends the first woman into space. And U.S. launches Project Mission Mercury.
Okay, so was there anyone else involved in this project?
Well, that's precisely my acquaintance that was there all along was Dr. Arno Penzias, who was actually at Bell Laboratories before I was, doing the same thing as radio cosmology. And other people who had influence in the project were physicists such as Robert Dick and Dave Wilkinson, and their work really gave meaning to what our results found.
Okay, so you talk about other people being present in the project. What was your role in the project compared to maybe some of the other people?
Well, of course, the physicists were behind the theories, but my role in Dr. Penzias was pretty much the same. We just worked in cahoots to, um, you know, we were in charge of operating, maintaining the antenna, and collecting the waves from space. What we thought was the wave was actually cosmic background radiation, but that's what we were just posted at that antenna.
Okay, so you talked earlier about how work from physicists, previous theories came in and kind of helped give meaning and clarify uh, what you and Dr. Penzias did in your experiment. After your experiment as a whole was released to the scientific world, what impact did your project have in turn on the physics community?
Well, it revolutionized the physics community. I mean, the effect was astronomical. It brought the study of cosmology from a subject only a few scientists dealt with, had expertise in, which many, frankly, thought were inferior to it. It became a serious branch of physics. The Big Bang theory went from being secondary to the steady state theory, which, if you don't know what that is says that the universe has no beginning, end, or has never changed. And the Big Bang theory became the primary theory of cosmology after that. Of according to physicists like Robert Dicke, it proved to be the cosmic radiation which emanated from the Big Bang Theory and should be around 3 Kelvin. In his theory as well, it was around 2.7, which is really darn close. Also, theories prove that the universe has been growing cooler since the beginning because it was almost infinitely hot, and also the universe has been expanding um, expanding at an accelerated rate, which was concluded by Edwin Hubble back in the 20s. So it really tied all those together.
Okay, so most scientists and physicists have at least one or two interesting stories about mishaps that happened during the experiment. Um, did you encounter any interesting mishaps while conducting your experiment?
We actually had a nest of pigeons that roosted in the satellite, which we eventually had to kill because we would try to catch them in these traps, which are now at the Smithsonian, but they would just come right back when they flew off. So we had to get rid of them and clean up the excrement and make sure they weren't tampering with our data and making interference that would disrupt the radio waves. So that was pretty interesting.
Okay, well, Dr. Wilson, I'd like to thank you for your time and thank you for coming in to answer some questions about the experiment you did so long ago. So thank you.
Thank you very much.